For question 4, we're told that at time t equals 0, a stone is thrown vertically upwards from ground level with speed u meters per second. We're told the greatest height above the ground is 2.5, and we want to find that initial speed. So if we are looking for our initial velocity, its greatest height will be when it b equals 0. The displacement will be 2.5. The acceleration is going to be minus 9.8 since it's going against gravity. Okay, so this is for part 1. So from this we can just use v squared equals u squared plus 2as and start to sub in. So we've got 0 is equal to our u squared and plus 2 upon minus 9.8 upon 2.5. So 0 will be u squared minus 49. So then u squared is equal to 49, therefore u is equal to 7 meters per second. For part 2, we're told that at t equals 1, a stone b is thrown vertically upwards from ground level with speed 5 meters per second. We want to find the time when a and b collide. So we're going to consider both the cases separately. We can work out an expression for the displacement of each of them. Then if we set that displacement equal, then we can rearrange to find out what the time is, and that'll tell us what time they're at the same distance away from the origin. So that'll tell us what time they collide. So if we look at A first, we now know that its initial velocity is 7, its acceleration is minus 9.8, the displacement is what we're going to find an expression for, and the time we're just going to call t. Okay. Then for B, its initial velocity is 5. Again, its acceleration is going to be minus 9.8. Again, we're going to be looking for the displacement, and this time the time is going to be t minus 1. So because it's thrown a second later, it's going to take a second less for it to reach that point. So we can use s equals ut plus a half at squared for both of these, and just fill it in to get an expression for s. So we're going to have 7t minus 4.9t squared. And then over here, again using s equals ut plus a half at squared, we're going to have 5 upon t minus 1 minus 4.9 upon t minus 1 squared. So obviously this is slightly more complicated, but we can look at setting these two equal to each other and working out what the value of t is. That value of t will tell us the time when the displacements are equal, and therefore the time when they collide. So if we go ahead then and set these two expressions equal, so we will have 7t minus 4.9t squared, that's equal to 5 upon t minus 1 minus 4.9 upon t minus 1 squared. So we'll have 7t minus the 4.9t squared is equal to 5t minus 5 minus 4.9 multiplied by t squared minus 2t plus 1. And again, just expand out that last bracket, which will then allow us to start to collect the like terms. So we've got 5t minus 5 minus 4.9t squared plus 9.8t minus 4.9. If we then collect the like terms, we'll see that the t squareds will cancel, which is good for us, and allow us with 9.9 equals 7.8t. So we put that into our calculator. T is just going to be 9.9 over 7.8, which will come out as 1.27 seconds, as always rounded to 3 significant figures.